For review question 3, expand and simplify each of the following expression. So before we start on this question, let's just recap back on all the 3 special identities that we have learned. And we have, first one, we have a plus b bracket square. That gives me a square plus 2ab plus b square. Okay, second one is very similar, just that instead of a plus b, it is a minus b bracket square, which is a square minus 2ab plus b square. And finally, last but not least, I have a plus b, a minus b, which is a square minus b square. Okay, keep in mind, there is no a square plus b square in my special identity. All right. Okay, so with this, I'm going to leave this special formulas, special identities over here. And let's begin with our part A. So 3x bracket 2x minus 3, basically this front portion over here, it's simple expansion, which is just bringing of my 3x into every single term in the bracket. And that gives me 6x squared minus 9x. However, as for the second portion, can you identify that this is actually a special identity? Right? X minus 2, I'm using this special product over here. And in this case, A equals to X, B equals to 2. Am I right? So that gives me X squared minus 2AB plus B squared. All right. From here, all I have to do is to simplify this portion and this part over here, and I can actually add them up already. Okay, so minus 2 times x times 2, that gives me 4x, and 2 squared is a 4. Now that I'm done with all the expansion, I can add up all the like terms together. I have 6x and 6x squared and x squared. That gives me 7x squared. Minus 9x and minus 4x, that gives me minus 13x. And I only have one constant term, which is a 4. Okay, and this is my final answer for part A. Okay, now let's try one more question. For part B, first portion over here, 3x plus 2b bracket square. Can you identify which special identity am I using? I'm using my first special identity over here, which is very similar to the second one, right? Okay, so for part B, in this case, A is my 3x, B it's my 2b. All right, so now I'm just going to plug it inside my formula. 3x, keep in mind, when I square my A, it's the square to the entire A, which is 3 and x. It's not just square to the x itself. All right, then plus 2ab, same thing, plus b square. It is square to the entire term of b, which is 2b. So this square belongs to 2 and belongs to b. Okay, and for the second portion over here, can you help me identify which special identity this is? This is actually the last special identity that we have not used. So if you can see A plus B, A minus B, meaning in this case, A equals to 3A, B equals to 2B. All right, and that gives me 3A square, keeping it in a big bracket, minus 2B square. Okay, so I'm going to expand all this up further. 3x squared, I get 9x squared, plus 3 times 2 times 2, that is a 12xb. All right, and then for this one, I have a 4b squared minus, because of this negative, I still have to keep my bracket. So later I can flip my sign. All right, this is a 9a squared minus 4b squared. Okay, now that I'm done with all my expansion, all I have to do is to remove these brackets over here. If it's a positive sign, I can just open up freely. There is no sign changes. But if there is a negative sign outside your bracket, please keep in mind that you have to flip the sign when you're opening it. All right, this gives me 9x squared plus 12xb plus 4b squared minus 9a squared plus 4b squared. Okay, now that this is just a normal linear equation, all I can do is to simplify further by adding all my like terms up together. So just take a quick look. I only have one x squared term. I only have one xb term. For b squared, I have 4b squared and 4b squared. That gives me 8b squared. And I only have one a squared term. And this is my final answer.